we're going to set up and go through a couple of these together. We're going to work together on how do you look at it visually. We're going to look at what the calculator is going to be able to help you do and solve with these things as well. Remember, we have a quiz I'm planning on Thursday that will be calculator, non-calculator. This would definitely be the calculator portion, all right? Because of the fact that we start to read through some of these values, you're not going to want to graph some of these weird numbers, okay? Which is fine. So the calculator allows us to search for certain things. So first thing we're going to do is look at the very first problem. You have a rectangular stained glass window that's 2 feet by 4 feet. You have 7 square feet of clear glass to create a border of uniform width around the window. What should the width of the window, or what should the width of the border be? What does uniform width mean?
Yes, we were going to say the width.
Yeah, just like you guys were saying, it's the same width all the way around. So what we want to do here is, first of all, draw a picture of a rectangle, 2 by 4. Not bad. It's a rectangle. One side length is 2, the other side length is 4. Be okay with that?
Yeah.
Now, if I want to draw a border of uniform width going around that, would that also be a rectangle?
Yeah.
Right? Now, do I know what the width is of that border? No. So what I'm going to do is I'm going to say that from here to here is X. Which means from here to here is also how much? X, good. You got it. X. What's up there? You said it. X. And then down here is? Okay. What are your outer new dimensions? What's that? Half a foot? How are you bringing half a foot? I'm saying, let me rephrase. What's your new outer overall dimension? What's that way? What is that? Two plus 2x. You were on the right track there. It's 2 plus 2x going that way. What is it going this way? 4 plus 2x. So from here to the door is 4 feet. I moved over X amount and the same X amount. Isn't that 4 plus 2x? From here to the door is 4 feet. Okay. I move over to the left X amount. So now it's 4 plus X. I move over the same X amount. I'm 4 plus X, otherwise known as 2X. All I'm doing is I'm adding going across. So you have X at the top border, 4 inches, and then that's the bottom. There's 2X's. As you're going across, think of this as X plus 2 plus X. Combine midterms. All right. Now, how do you find area of a rectangle? Base times height, length times width. Doesn't matter which one you say. No. So my new area would be 2 plus 2x by 4 plus 2x. Everybody okay with that? Okay. Now, what we're trying to do is we're just trying to figure out the area of that border, though, right? Very good, very good. You got to take out the middle. Good, that was awesome. So what was the middle? 8. Very good. Say what? So now, what does this have to equal? It has to equal 7, because how many total square feet did you have from the border? No, not, oh, it's 7. Oops. So this has to equal 7. So first thing you're gonna do. Why? We don't have to, do you?
Put the 7 on.
Why not just FOIL first?
No, I'm gonna. I should have.
If I FOIL this out, we had 8 plus 4x plus 8x plus 4x squared minus 8 minus 7 is 0. Okay. I'm setting it equal to 0, just move everything over. I FOILed it out. Start combining like terms. I get 4x squared plus 12x minus 7 is 0. Are we okay with that? All right. How do I get what? What's that? You all right? I thought you said, how'd you get it? All right. So from here, what do? Okay. What times what's 28? Negative 28. 14 and negative 2. Good. So now you have 4x squared minus 2x plus 14x minus 7 is 0. Remember my trick, whenever you have a positive and negative value when you're factoring? Yeah. You put negative first, it's just cleaner. Now we do our GCFs like we have been. So I have to take out a 2x. I have a 2x minus 1. Take out the 7. I have 2x minus 1. This gives me terms of 2x plus 7 and 2x minus 1 that I have to find zeros for. One of those answers makes sense, the other one doesn't. Which is which? It's the one. Why does that one make sense? Correct. Can't have negative distance. That value of x cannot be negative because negative distances don't exist. Yes, ma'am? More often than not, they don't. More often than not, they wind up like this. Okay? So. What? Oh, is that when you have to have to run away? Okay. Are you serious? I was wondering why you figured that out that fast, but hey, fast enough. Blind squirrel finds a nut every once in a while, right? No, that's good. Very good. Now the idea here is, guys, the idea was that you still had to be able to come up with the idea of what does it visually look like, the picture. You still had to be able to FOIL. You still had to set up and factor. This was a factorable problem. This wasn't so terrible. Border of uniform width is a very similar style problem that you see from time to time again. Let's see. Let's switch to number 99, the athletic wear one. Second page, bottom one. Oh, sorry. It's the second page. Whatever. All right, sue me, okay? I can't read. Exactly, I'm a math teacher, not a read teacher. Right. Okay, all right, fine, you win, Sarah, you win. I know.
You made this
Again. All right, a shoe store sells 200 pairs of new basketball shoes each month when they charge $60 per pair. For each dollar increase in price, about 2 fewer pairs are sold per month. How much per pair should the shoe store charge to maximize monthly revenue? What is the maximum revenue?
This sounds like this is a constraint problem.
It's a what?
Sounds like a constraint problem.
Constraint? No, it's not constraint, but it says maximum. So it says maximum, which means what should it look like?
Oh, down like a frown.
So it should be down like a frown. If it's going to be down like a frown, that means somehow, some way, our A value has to end up being negative. Okay. So when you have these cost style problems, we're talking about quadratics. We're trying to figure out at what price things work. Well, when you're looking at it, they told you two prices. Oh, I guess I can go to the right page that has that. They tell you two bits of things. And 200 units, 200 pairs of shoes are sold at $60. So 200 shoes are sold at $60. Okay. If I multiplied those two together, it would tell me how much money you make off of those shoes, how much money income you brought in. Not talking about profit or anything here, it's just how much money you're bringing in. Now it says for each $1 increase in price, 2 fewer pairs are sold per month. So when you're looking at this style, you've got two basic factors that are going on. You have sales, like sale units, and you have price. Now, there's a common multiplier that is occurring within these. It says for each dollar increase, 2 fewer pairs are sold. So if I increase it 4 times, what would be my new selling price? It'd be 64. I'm taking that multiplier of 4, multiplying 4 times the $1 increase in price. For each 4 times I do that, I have to take that 4 times 2 for the number of less that it's selling. That value is the x. The number of times things that are changing is the x value. The increase or decrease is the constant that's with it. So for every increase of $1, you have a decrease of 2 sales figures. And that's how your A value becomes negative. Now, that x value isn't representing either cost or sales. All it's representing is the number of times things change. That's all that represents.
Yeah.
Okay? That's all that represents. Yes, I know updates are available, and I'm really sick and tired of you telling me. Because every time I update, 20 minutes later, there's more. And it's just really annoying that I have to be. So, in this case here, what form is that? It's intercept form. What does intercept form allow you to find? Your zeros, right? So if this is my intercept form, where are my 2 zeros? One's at 100, right? One's at 100, the other one's at negative 60. What? It's just intercept form. Set those equal to 0. Okay. We know that the vertex has to be above it. You guys told me that it's a maximum, which means the A value will be negative. We FOILed it out. What I'm trying to get at here is we don't need to FOIL it out. We don't need to figure all that out because it's set up for you in such a manner that if you understand that it's set up in intercept form, get your intercepts. What always occurs halfway at the intercepts? And what's the x value of your axis of symmetry? 20. Well, okay. And this, but what does that represent in terms of the graph, though? It's the x coordinate of your vertex. It's not the maximum. Okay. See where I'm going here? So everybody. I thought you said sumi. I'm like, oh, that's good. No. So everybody okay that if I add these two together, I get 40? Yeah. What's half of that? 20. So where's your axis of symmetry? 20. So there's my axis of symmetry is at 20, which means somewhere up here is the vertex. 20 is the x value. What do I do to find the y value? All right. So what's 20 times 1?
20.
What's 20 plus 60? 80. All right, so 1/2 of it's 80. What's 20 times 2?
40.
What's 200 minus 40?
60.
So we got to figure out what 80 times 160 is. You might be able to. I think I did that right. Is that right? Did I miss a 0?
Yeah, you went over.
Oh. Anyway, so what was the answer?
12,800.
Bravo.
Okay. Now here's the thing. Remember, did that x value represent cost? Did that x value represent sales figures? The x value just represented how many times it increases or how many times the price changes. The 12,800 represents monthly revenue because that's what the function we made. Your monthly revenue will be at 12,800 on those shoes if you sell them for how much? $80. Very good. The $80 represents the maximum selling price that you can do. Okay? Yeah. All right, remember, this is our sales figure. If we change it 20 times, it gives me my maximum. My sales figure is $60 plus 20 times 1, $80. That's where the $80 comes in.
So the answer is 12,800.
Depends on what's asking. It asks what the monthly revenue, how much per pair should the store charge to maximize monthly revenue? They should charge $80. What's their monthly revenue? Yeah, that's what that means. It sounds weird as you work through it, we don't have time. So, you want to come up to the other ones? The other ones that we have for are basically pure calculator based. And we got another sheet with some of those. They're also kind of intertwined in this one too, but I want you guys, I should have just stapled all of them together, but it's no big deal. Yeah, there's a whole bunch of these things.
I didn't get all.
Do not like that.
Ladies and gentlemen, come on. Hey guys. So, ladies and gentlemen. Oh.
Okay, so these problems are similar to the ones that you have been doing, except they actually give you the equation that you're looking for. So it's a little bit nicer. The only thing is they do change variables on you, so you have to make sure you understand what the variables represent. In this case, with John is hitting baseballs, we have the equation h equals 5 plus 25t minus 16t squared. So what would our t's represent in this case? X values, and then h would be 1. Time is correct too, and then h is height, yes, but in terms of variables in the x-axis, the y-axis is what I was asking. So then, what is our a value? Is it positive or is it negative? Negative. So what does that mean in terms of our graph? What is that going to look like? Down like a frown, correct. So we're going to have some type of maximum somewhere with the vertex at, what do we think the vertex is going to be at? What's our...
I don't think you have to worry so much about the vertex, but what value do we know for certain?
Oh, yeah. Yeah.
What value do you guys know that it goes to for certain? Why? Excellent. Yep. It's got to go. It's got to go through. Everybody see that? It's got to go through 5.
Yeah.
And the reason it has to go through 5 is that it is the C value, even though it's written backwards. It's just written up that way. Excellent. Excellent.
What's nice about these is you can use your calculator on them. Does everyone know how to graph on their calculator? Yes? Okay. This is, how do you use this?
Oh, if you click. Oh my God. You want to try this one? It's not showing up. Come on, guys. We got a lot to get through here.
Okay. So we can type it in.
Here, you want to talk? I can type.
So type in 5 plus 25t minus 16t squared.
X's are fine for the calculator here. Remember, the variables don't matter. It still works out the same.
Still there? Oh no.
Oh, you're typing.
Sorry, we didn't have a 16.
Go ahead.
Okay, here you go. So then, graph it. Do I enter?
I got it.
Okay. Cool. So. Oh no! Did you put the negative sign in for the 16 as a minus? No. Okay. That is probably they're gonna get the right graph.
Now remember, guys, with stuff like this, you'll have to mess with the window.
Yes.
Okay. The button that says window allows you to change your parameters.
It's the second at the top, the white. So if you can see over here, kind of the region. So you could do window, and then you could change it here, or you could do a zoom.
It doesn't automatically.
And then if you want, you could do a zoom fit and zoom out from there. Because zoom fit will try to fit it to the best window, but then if you can't see the whole thing, you could zoom out from there. So like we kind of can't see where our max is for which one, the zoom fit.
Yeah.
So you go into zoom.
Okay.
And then you go to zoom, and then you scroll down to, I think it's 0. And so you could hit 0, and then it'll zoom fit. And then if you can't see it all, you could hit zoom again. And then you can zoom out from there. And then hit enter. And then you'll see it a little bit more clearly.
Or just keep messing with the window.
Or yeah, you could
Mess with the window. I've always found that windows are a little bit cleaner.
whatever you guys have your preference for is like whatever is easier for you. You should still get the same thing when you go to find your intercepts. So we want to find where t is in. So we want to find the height of the ball where t is. Okay, so that's our equation. So then we want to see how much time will pass before John hits the ball, and we know that John's going to hit the ball when the height of the ball is at 4 feet. So to see this, we could go to our table. So by doing table, you could hit second and then graph to get your table. So does anyone see kind of the issue we have with our table? Yes, it's a little bit like we can't see. We know that there's going to be 4 is going to happen between -1 and 0, but we can't really see where our 4 is going to be for the y for the height. So what we can do is we can go to the y equations again. If this will work, there we go. And what do you guys think we could do here? Does anyone have any idea? To find where our parabola hits at y equals 4. What? I'm sorry. No. Yes, correct. So we want to pick another line at y equals 4 so that we can find that intersection point. So type that in, and then we'll graph it again. So yeah, so you could kind of see that the window's kind of screwed up with all the zooming, so I'll change it really quick. Gosh. Oh my goodness. Yeah. It's like not letting me.
Change this to. Oh, here, I just changed it.
Okay, go ahead. Yeah. Thank you. Okay, so then does anyone know how to find the intersection?
Ladies and gentlemen, real fast before we get too far here. I need everybody to hit the button on their calculator that says window. On your window, I want your, you hit window real quick?
Yep.
On your window, X min, -5, X max, 15, Y min, -5, Y max, 25. What happens a lot of times here, guys, you have to fish for the window. You have to play around with it and try to mess around and try to find the entire graph. There's no set one way is always going to work with these. It's just a lot of times with the window, it is trial and error. Okay? Sorry.
No, you're fine.
It's just one of those things you just kind of.
Yeah.
All right.
No worries.
If you get syntax error, that means you put your max mids backwards.
Okay, so then to find our intercept of the lines, we're gonna do second and then hit trace because that'll make us go into calculate. And then if you hit number 5 from there, you could find your intersect. So our first curve, it doesn't matter what you pick for your first curve, just make sure you do the 2 different lines on the graph. So we can make the red one our first curve. We'll just go before the intersect on here. And then our second curve can be our blue line, which is at the parabola. And then you can just get as close as you can and then hit enter once you've done that twice. And then that's our intersection point, is when the time is 1.60 seconds. So that's how we find when John hits the ball. And then that's the maximum height of the ball. So this will be our maximum point. So again, we can use the calculator and hit second and calculate to then do maximum, which would be 4. So you can click 4. And then we want to get close to the maximum point as we can. So we're going to do the left side first and hit enter. And then we have to do the right side of the maximum point, hit enter, and then hit enter one more time because it's going to ask to guess. And then you'll get your maximum here. So the maximum height that John hits the ball is 14.76 feet. Are there any questions about using the graph to find these points?
On the sheet we just gave you guys, because I know we're running real short here on time-wise, I want you guys to give these a shot for, let's see, we just did the baseball one. 1, 2, 3. Try those next 4, okay? Where you've got the projectile launched vertically, the formula of an object thrown, basketball, and the Autobahn. one, okay? Try those 4. It's all straight calculator work about messing around with your window sets and everything. We'll continue talking and working through these things tomorrow. We'll go back to the other sheet as well. So, thought we would have more time. It happens. No big deal. All right? Wait. No, don't worry about it. It's fine. No big deal.